start our lecture. So the video is on, and I hope that everyone is getting my shared screen and again a video. Also, I started the recording of the lecture. So today, how the participants, that is the students attendance is the 19 students are there. But after requesting them many times, some of the students they are going to log with the only name and any another different name. So don't use the any other different name here. Only use the your roll number, your division, okay, and again your first name and again the last name here. You kindly circulate this message to your all friends, okay. So we'll see that what we have covered in the previous lecture, and then after we'll see that what is the today is our agenda. So we started our classical substitution ciphers, okay. So the classical substitution ciphers are nothing but these are the algorithms where we are going to substitute the plain text character with a cipher text character here, okay. So the such algorithms are called as the classical substitution ciphers, okay. So the Caesar cipher we have covered. So and again already we saw that the monoalphabetic cipher. So in case of the monoalphabetic cipher, this algorithm we have studied, and a frequency analysis. So for frequency analysis also we studied about that. So which letters they are going to occur the frequently. So that also we have studied. So this is the English letter frequencies, okay. So these are the English letter frequencies you can see here. The horizontal side we are having the characters, that is alphabet, and again at the vertical side we are having the relative frequency in a percentage, okay. And the percentage for the E and again the T and again for O and again N, S, again I, H, okay. These are the letters are having the highest relative frequencies in percentage, okay. And now today we are going to cover the Playfair cipher, okay. Playfair cipher, that is the very easy algorithm. We are having some important algorithm, Playfair Key Matrix. And again after that we have the polyalphabetic cipher. So here is the polyalphabetic cipher also we are going to learn. The polyalphabetic cipher is also called as the visionary cipher, okay. So the simplest polyalphabetic substitution cipher is the visionary cipher. So we'll see that what is the visionary cipher here, okay, how you are going to cover. And next one is already we have covered the one-time pad. So what is the one-time pad algorithm? That also we have covered in the previous lecture. So now we start our very important algorithm. So that algorithm is called as the Yes, due to the network issue, I am not able to connect properly here. So now I have connected with proper connection. So I hope that I will not get any disturbance for this lecture. So the very important algorithm we are going to study in today's lecture. So I will explain first of all how it is going to work here, because whatever the algorithms we have studied in the previous, so these algorithms were very easy. Okay. So now today, whatever the algorithm we are going to study, this algorithm is having the some different concept. Okay. So we'll say that how that algorithm is going to work. So this is the Playfair cipher algorithm. So how the Playfair cipher algorithm is going to work here. Okay. So the name tells that the Playfair cipher. Okay. So how the Playfair cipher is going to work, I will explain you this one. So this algorithm is having some different kind of the algorithm. Okay. So it is based on one a matrix. Okay. So that matrix size is 5 by 5 matrix. It is there. Okay. So in case of that 5 by 5 matrix, we are going to implement the Playfair cipher algorithm. Okay. So in that Playfair cipher algorithm, so whatever that matrix is there, so you know about the matrix, the number of rows and again the number of columns are there. Okay. So in that number of rows and again the columns, so here we can see that the 5 rows and again the 5 columns. Then why we are going to consider this matrix here? Because see, we have the 26 alphabets. Okay. So the 26 alphabets we have, and out of that 26 alphabets, as compared to the this 5 by 5 matrix, so 5 into 5 is equal to 25. So that here we are having the 25 places will be there in the matrix. So that we are going to place all the 26 letters into that matrix. But one more letter is not accommodating in the 5 by 5 matrix here. Then at that time, somewhere we are going to adjust 26th characters or the alphabets in that 5 by 5 matrix here. Okay. So how it is going to work? So we'll see the example also. So this is the scenario just I have told you about the Playfair matrix. So in this Playfair cipher, we are having the 2 steps here. So one is that we have to construct first of all a 5 by 5 matrix. Okay. So and the second one is that we need to apply the some rules, and after that we are going to evaluate the cipher text here. Okay, these are whatever these steps I am going to tell here. These steps you have to remember here. Okay. So then and then only we are able to perform the encryption and again the decryption process here. Okay. So in case of the Playfair cipher, so not even the large number of keys in a monoalphabetic cipher provides security. So this is the drawback of the monoalphabetic cipher was there. So that's why we are going to apply the Playfair cipher here. Okay. So not even the large number of keys in a monoalphabetic cipher provides security. And one approach to improving security was to encrypt multiple letters. Now, what is the speciality of the Playfair cipher here? So whatever the previous algorithm we have studied that all the algorithms where we have converted, we have encrypted the only single character at a time. Okay. And we have decrypted the only single character at a time. Okay, in the previous algorithm. And in this Playfair cipher algorithm, we are going to use the approach of a encryption of multiple letters. Multiple letters means more than one letter at a time. We are going to have the encryption here. So that is possible in case of the Playfair cipher. 1854. The friend Playfair. So these two friends have been implemented the Playfair cipher in the 1854. You can imagine that. Now we are in the 2022. How concept here. So once again I will tell you that the Playfair cipher, not even the large number of keys in a monoalphabetic cipher provides a security. And one approach to improving security was to encrypt multiple letters. And the Playfair cipher is an example. It is invented by the Charles Wheatstone in 1854, but named after his friend Baron Playfair in the 1854. Okay. See, now this is the 5x5 matrix is there. So what is that 5x5 matrix here? So the Playfair Key Matrix, it is called as the Playfair Key Matrix here. Now here you can see that a 5x5 matrix of letters based on a keyword. Fill in letters of keyword, that is we need to avoid the duplicates here, and fill the rest of the matrix with the other letters. Okay. So for example, using the keyword. So how you are going to construct the Playfair Key Matrix here? So the first of all, we need to select a keyword here. So that keyword, it may contain the multiple letters. A small keyword we should not use here. Okay, why? Because if I'm going to use M, Y, okay, R, then these letters are having these keywords are having a very small number of letters will be there. So at the time of the selection of the keyword, I have to choose the such keywords which are having the more and more characters, and the many letters should not be repeated again and again. Okay, such types of the keywords we need to select here. Okay, and we need to arrange that keyword into the 5x5 matrix here. Now here we have this is the first row, and again the second row, this is the third row, fourth row, and again the fifth row here. So we need to write this keyword. So the keyword is monarchy. MONARCHY. So here I'm going to write the row wise the keyword. So the first of all I'm going to write the M. Again the O is there. Again the N. Again the A. Again the R. Okay. Again the C. Again the H, and again the Y. So in this keyword, so you can observe this keyword here, monarchy. Any single character is not repeated again here. Okay, not a single character is repeated here. Okay, the every character is occurred at the only once. Okay, that is the monarchy. Now, what about the remaining places in this matrix here? So the remaining places in this matrix is that. So now you can start with the A character here from the A to Z. Now you can write the A here. So the A is already covered in the monarchy keyword in itself. So we cannot write the A here. So you can go for the B. Observe the B here, whether the B is written here. No, the B is not written here. So that is why we need to write the B. Again, the C will be there. So the C is already covered into the keyword. So the C is there. So we need to write the D here. Again, the E is there. F, G. Now we come for the H. So the H is there. Okay, already it is covered. Now the I and J. Why I have written the I and J here? Because so there is only we have the 5x5 matrix, so that only we have the 25 elements we can insert into the matrix here. So here what the Playfair suggested that it is feasible to combine the I and J. So there is no any restriction to write the I and J only here. You can write the any combinations here. Okay, but the Playfair he has written the combination of I and J. As an example, you can take the any combination. Okay, there is no any restriction is available. The next one is the K, again the L, P, Q, S, and again the T, U, V, W, X, Y. So the Y it is there already. So no need to write the Y. And again the Z. Means in that way, all these 5 by 5 matrix, it is going to cover our all the alphabets here. Okay. So in that way, you can construct the 5 by 5 matrix here. Okay. So in that matrix, now you can observe here, every character is covered in this matrix here. Okay, every character is there. M, O, N, A, R, C, H, Y, B. Here. Okay. So here you can see that each and every character is covered in this Playfair Key Matrix. Now I think you got it, how you are going to construct the Playfair Key Matrix here. Okay. So the Playfair Key Matrix, in that way we are going to construct here the Playfair Key Matrix here. Okay. Now, how you are going to perform the encryptions? Okay, that is important. For performing the encryption, it is we are having some rules are there. So how that the rules they are going to work here, that we will see here. Okay. So these are the rules for encrypting and again for the decryption purpose. So we'll see that what are the rules and now here you can see that the plain text encrypted 2 letters at a time. You remember this one. Whatever the plain text letters are there, these plain text letters are encrypted 2 letters at a time. Okay, this is very important. This is the speciality of this Playfair matrix here. Now, for example, you can consider if a pair is repeated letter. If a pair is repeated letter, you insert a filler like X. For example, suppose your plain text is having the balloon. Okay, then we need to make the 2 letters of this balloon plain text. Okay, suppose for example we have the first is BA. Again we have the LL will be there. So these 2 letters they are going to repeat here. So that's why we need to fill some letters like X. So the LX. Again the next one is the LO. Again the ON. This in that way we need to write the diagram of the balloon here. Okay. So if both letters fall in the same row, replace each with a letter to right, wrapping back to start from head. Now here I can see that. See how you are going to perform the encryption and again the decryption. Okay. So in case of this encryption, so the first of all, whatever the plain text letter is there, that plain text letter we can make the diagrams of that plain text. So what is meaning of the diagram here? So that this diagram is different. I will tell you the spelling of the diagram. That is the DIGRAM. The diagram. Diagram is what here? So the any plain text letter is there. From that plain text letter, we are going to create a group of 2 letters from that plain text. Okay. So whatever the first rule is there, that first rule is related to the diagram here. Okay. Now the second rule, what suggests the second rule here? If both letters fall in the same row. Okay. If these letters, what is the BA, LX, LO, ON is there, if both letters fall in the same row, replace each with letter to right, wrapping back as start from end here. Okay. So we are going to consider this row here. Okay. This row is like at the cylinder like. Okay, this is the cylinder. From the end again it will start from the start. Okay. From the end again it will start from the start here. Okay. That way cylindrical like it is there. Okay. Now you can consider, for example, AR is there. See our letters are the AR, it is there. So where the AR is coming here. Okay. So here I will use the annotation. Okay, whatever we have the AR, it is there. A and again it is we have the R here.
So where the AR is going to occur here? So the AR is going to occur into the first row here. Okay. So what I am going to tell here, whatever these rows are there, these rows are the following the circular fashion. Okay. So here you can see that. So this is the circular fashion. Means after the R again what will come here? Again the M will come here. Here what will do here? After the D again C will come here. Again for the K, what will come here? Again for the E. Again for the T, what will come for the L. Again for the Z, what will come here? The U here. Okay. So I will need to write, these are the plain text characters. Okay. So these are the plain text characters are there. Now I need to write the ciphertext character here. So what will be the ciphertext character for A and again the R here. So now the first of all we need to observe that whether A and R, whether they are going to occur into the same row or not. Now here you can see that A is in the first row and again the R is also in the first row here. Means whatever the A is there, so we are going to consider the ciphertext character for the A to the right letter. So what is the right letter here? So the right letter is the A to R is the R here. Okay. So here we can write the ciphertext character for the A is R here. And again for the R is there. So what is the R here? Next, what is the next character of the R here? So the next character of R is the M here. So here we are going to consider as the M. So that is, it is called as the M here. Okay. So this is the ciphertext character for the A and R. That is the R and M. Okay. So now the next one is that. Okay. So what is the next one here? Again for the next one, it is that. Now here you can take the any another characters. So what are these another characters here? So the another characters you can take as, again I will use the annotator here. Okay, now you can take the next one is that the Q and S. Okay, the Q and S again where they are going to occur here. This is the Q and S. Okay, where it is going to occur here. In the same row it is going to occur. So what is the ciphertext character for the Q and S? It is the S and T here. Okay, see the S and again the T here. Now we have the U and Z. So what will come for the U and Z here? This is the U and Z. So what will come for the U and Z? For the U will come as the V here. Okay. And again for the Z it will come as the U here. Okay, this is the very easy. Once we are going to understand the rules, that is very easy to understand the encryption and again the decryption process here. Okay. So now we have completed the one rule, the letters where they are going to occur into the same row here. Now, can you imagine that what will be the second rule here? If the letters they are going to occur into the same column here. Okay. The third rule you can consider here. What is the third rule here? The third rule is that if both letters fall in the same column here. See, I am repeating once again. If both letters fall in the same column, then replace each with the letter below it, again wrapping to top from bottom. For example, MU encrypts to the CM. Okay. We'll see that what is the same column here. See, whatever I told you that the row wise, the same concept we are going to apply for the column also. Suppose this is the first column, second column, third column, fourth, and again the fifth column here. So at the end of this column here, U, again it will start from the first here. See, like it is like that. Suppose after the U, so again what will come here? So again the M will come here. Okay. So this is the circular fashion. Again the okay. After the Z, what will come here? After the Z again will come as the R here. Again for the U, okay, again for the U, O will come. Again for the W, N will come. Again for the X, what will come here? A. Again for the Z, it will come as the R here. Now we'll see that what is the one example we'll take. So one example is that suppose we have the MU. Okay. The plain text characters are the M and again the U. Okay. So in that MU, so first of all, you need to check that where the MU is going to occur here. So whether the MU is going to occur in the first column here, yeah, it is in the first column here. So for the M, the letter, next letter of the M is, okay, what is the next letter for the M? That is the C here. And the U, so the U is last letter. So what is the next letter for the U is M here. Okay. So in that way, we can write the CM as, okay, the CM as the ciphertext. Okay. So this is the CM is nothing but the ciphertext, and these are the called as the plain text character here. Okay. Now you can take the any another example. Okay, what is that? Any another example you can consider here? I can take the A, B. Okay, where is the A and B? So the A and B is going to occur into the fourth column. Okay, just you can observe here. So this is the A and again the B here. Okay. So this is the B. So these are the plain text characters here. Okay. And for A, we have the ciphertext character is B here. And again for B, we have the I. Okay. Otherwise, also you can consider B and J here. Okay. Because in the next letter we have the I and J a combination here. Okay, we can have the B and I and again the B and J here. Means in that way we can have the these ciphertext characters for the A and B here. So these are the ciphertext character here. I told you that the any combination you can take, but Playfair suggested that you take the I and J the combination here. Okay. So this is about the same column here. Now can you imagine that what will be the next rule here? We applied the same row, same column. Now what will be the next rule here? So the next rule is that if otherwise, okay, otherwise each letter is replaced by the one in its row. Okay. Otherwise each letter is replaced by the one in its row in the column of the other letter of the pair. For example, HS is encrypted to BP and EA to IM or JM as desired. Okay. So here you can see that if the letters they are going to occur into the different rows and different columns, then how you are going to have the encryption. So that is the fourth letter here. Now here you can see that HS, it is encrypted as a BP here. So where is the H and S here? So you can take the annotation again. So this is the H and again S. Okay. So these are the called as the plain text here. Now where is the H here? So the H is here. Okay, so this is the H, and again where is the S? So the S is here. Now here the H is occurring in this second column here. Okay, and the S is occurring into the fourth row here. Now for the H, you can see here. So this sub matrix we are going to consider here. Okay, the H, Y, B, and again F, G, G, I, J, and again the P, Q, S. Okay, so here we are going to observe here. For H, the ciphertext character for H is the B here. Why it is because B here? Because this is occurring into the S column here. So for the H, I am going to write the B here. And again for the S, so what will the S here? So the S is, for the S, I am going to consider the P here. The P is the ciphertext character. Why it is going to, I am going to consider the P here? Because it is going to occur into the H column here. Okay, in that way we are having the whether the plain text letters they are going to occur into the different rows and different columns here. So this is called as the ciphertext character here. Now the one more example you can consider. Suppose I have the plain text characters. Suppose the plain text character is the N. Okay. So this is the plain text character is the N, and again after that one more character I will take the B. Okay, these are the plain text here. So what are the ciphertext character for this plain text N and B here? So where is the N is going to occur here? So the N is going to occur here, and again the B is going to occur here. So for the N, the plain text character, ciphertext character is the A. And again for the B, the ciphertext character is the Y here. Okay. So these are the called as the ciphertext character. Now the one more you can take. The plain text characters are F and T. This is the F, and again this is the T. So what are the ciphertext characters for this one? For the ciphertext will come as the, what will come here? The K. Okay. And for the K, what will come here? For the P. KP. Means in that way we are able to perform the encryption process with the help of the Playfair cipher here. Okay. So this algorithm is the very easy. Just you need to remember the Playfair key matrix, and again you need to remember these are the important 4 rules are there. So what are the different 4 rules are there? So the different 4 rules are nothing but, so the first of all we'll see the once again what are the different 4 rules are there. Okay. So I'm going to explain the once again the rules. So the plain text encrypted 2 letters at a time. First rule is that if a pair is a repeated letter, then insert a pillar like X. For example, balloon. So the balloon is encrypted as BALXLOON. The second one is the if both letters fall in the same row, replace each with a letter to right, wrapping back to start from end. For example, AR encrypts as RM. And the third rule is about if both letters fall in the same column, then replace each with the letter below it. Again, wrapping to top from bottom. For example, MU encrypts to CM. Otherwise, each letter is replaced by the one in its row in the column of the other letter of the pair. For example, HS encrypts to BP and EA to IM or JM as desired. Okay. So these are the different 4 rules are there for encryption of the a Playfair, a cipher here. Okay. So once again, now we will take the revision of this Playfair cipher. So in case of the Playfair cipher, so not even the large number of keys in a monoalphabetic cipher provides security. And the second one is one approach to improving security was to encrypt multiple letters. And the third one is about the Playfair cipher is an example. So the Playfair cipher is invented by Charles Wheatstone in 1854, but named after his friend Baron Playfair. Okay. So the first step is how to construct the Playfair key matrix. Okay. So we have the 5 by 5 matrix of letters based on a keyword and fill in letters of keyword. So avoid the duplicates and fill the rest of the matrix with other letters. For example, we have taken here using the keyword monarchy. So here we have constructed the 5 by 5 matrix, that is monarchy, CHY, BD, EF, G, IJ, K, LP, QST, UV, WX, YZ. And these are the encrypting rules, and again for the decrypting, the rules are there. Now, what is the security of the Playfair cipher? Okay. Proved over monoalphabetic. Since we have the 26 by 26 is equal to 676 diagrams. So what I have to letters from a DIGI front, and this DIGI the point of the pair of here. We would need a 676 entry a frequency table to analyze, okay, versus 26 for a monoalphabetic, and correspondingly more ciphertext. It was widely used for many years. For example, US and the British military in World War One. Okay, in the World War One, they have used this Playfair cipher. Then you can imagine that how much it is old. And it can be broken given a few hundred letters, still has much of plain text structure. Okay, this also we cannot, one thing I want to tell you that, so in information security, we cannot assure that. So this algorithm or that concept is very much secure, or it will provide the 100% security. It never happens. Okay. Because everything is available in the market, on the internet. You can download it, you can analyze it, you can study it, you can implement it, you can find out the loopholes, you can find out the advantages, you can find out the disadvantages, like that it is there. So the nothing is provide the more security. Okay. Otherwise, you cannot say that this is the 100% secure. Okay. The everyone is having the different kind of the loopholes. Our work is that as a third party or third person, we need to identify that what is the loophole. Okay. There we have to work. From there we need to give the more focus. Okay. So after all, this is the working of the Playfair cipher here. So I hope that everyone has understand this one. So then also, if anybody is having the any doubt or the any problem, just I'm going to enable the chat window here. So in the chat window, you can raise your questions, or you can ask the questions here. So now the chat window I have enabled here. So I request you all, please, anybody has having any doubt or any problem, just you can raise the questions in the chat window. So I think there is no any doubts or any problems. So I request you all, you please put your roll numbers for attendance purpose.